Hi class, I just wanted to make a supplementary video to get the last couple pages of notes from class A. There's a few examples of parabolas I want to do for you, as well as I think some line and a parabola intersecting. So let's do these relatively quickly. So I want to graph this parabola, y equals 2x squared minus 5x minus 3. I'm going to do it the same way I always do it, by first finding the vertex, then the y-intercept, and then x-intercepts if we have any. So to find the vertex, we're going to find the x-coordinate first. We're going to do negative b over 2a, which is going to be negative 5 over 2 times 2. This pen is terrible. That's going to be 5/4, which, yes, it is a fraction, which we haven't dealt with before. It's fine. To find the y-coordinate, we're going to plug in 5/4 for x. So we're going to get 2 times 5/4 squared minus 5 times 5/4 minus 3. This pen is also terrible. Okay. So simplifying this, we get, let's see, 2 times 5/4 squared is 25 over 16. 5 times 5/4 is 25/4 minus 3. 2 times 25/16, we can cancel 2 here and 2 here to get 25/8. So you get 25/8. Getting a common denominator, multiply this by 2 over 2 and get 50/8. Multiply 3 by 8 over 8 and get 24/8. 25 minus 50 is negative 25, minus 24 is negative 49/8, which is close to 6, or negative 6 I should say. So my vertex here is the point 5/4, comma, negative 49/8. The y-intercept is just negative 3, right? If you set x equal to 0, you're going to get y equal to negative 3. And then I think this we should start graphing it. So let's see. So most of the stuff is below the x-axis. I'm going to draw it like this. So my vertex is at 5/4 and negative 49/8. So it's like, I'm thinking like this is 1, 2, 3, 5/4 is like there. So it's like down here. So it's my vertex, 5/4, negative 49/8. And then my y-intercept is 0, negative 3. So maybe like, you know, this is about negative 6. It's probably like halfway between, so maybe like here-ish. So definitely means I'm going to have x-intercepts, right? Because my vertex is down here, and then there's a point here, so it's going to go up this way. So I can even draw it now. Ooh, I can try to draw it. And try and maybe move things. This is why I don't like to draw little marks. Just label things instead. And then obviously I have x-intercepts. So if I have the x-intercepts, we're going to set this equal to 0. 2x squared minus 5x minus 3 equal to 0. There are many ways to factor this. I'm just going to factor it by guessing. So I need to multiply the 2x squared, so I have 2x times x gives me 2x squared. I need to multiply the negative 3 and the negative 3 here and the positive 1 here, so that I get plus x minus 6x, which adds up to minus 5x. And then looking at each of these factors, this one's going to give me, this one's going to give me x equal to negative 1/2. This one's going to give me x equal to positive 3. So I get the x-intercepts 3, 0, and negative 1/2, 0. Okay, not too terrible. Let's look at the next example that we've got here. Yeah. So I want to find where the parabola y equal to negative x squared plus 6x and the line y equal to 2x plus 3 intersect. So the way we find where two things intersect is by substituting one thing into it. That's not super specific. But it's like saying y equals negative x squared plus 6x and substituting that in for the y here. Or in this case, since we've got them both solved for y, you're just setting the equations equal to each other. So I'm going to set negative x squared plus 6x equal to 2x plus 3. But really you can think about, I'm just substituting this in for y there. So then I'm going to bring everything to one side. I like to bring things to the side where x squared has a positive coefficient because I'm better at factoring that way. So I'm bringing everything to the right. So I have 0 on the left. I'm going to add x squared. I'm going to subtract 6x. 2x minus 6x is negative 4x plus 3. And then this does factor relatively easily. I'm going to multiply 3, but add the negative 4, that's going to be a minus 3 and a minus 1. So let's multiply the positive 3 and add them to negative 4. So my points of intersection, not the x-intercepts, but the points of intersection are going to be when x equals 3 and x equals 1. But if I want to find the point, I actually have to find the y coordinates as well. So looking back at either equation, I can plug in x equal to 3 and get the y value. I'm going to pick this equation because it's easier to plug into. So I plug in 3 here. If x is 3, y is going to equal 2 times 3 plus 3, which is 6 plus 3, which is 9. So 3 comma 9 is one of my points of intersection. And if x is 1, if I plug in 1, y equals 2 times 1 plus 3, I get y equal to 5. So that's going to be 1 comma 5. And those are my 2 points of intersection. I would get the same values if I plugged in here. If I plug in 3 here, I get negative 9 plus 18, which is 9. If I plug in 1 here, I get negative 1 plus 6, which is 5. So either way will work. Just pick the equation that's easier to find y values. Then the rest of the problem says I want to graph it and kind of shade the region that's in between them. So I'm gonna show maybe a little bit less work than I normally would for graphing. Maybe I'll just erase all this and 3, 9, and 1, 5 are my points. Okay. So we know they intersect at. I'll try and draw a nice-ish graph here. I could also show you on Desmos later on how to shade the region between 2 graphs. So there are my points 1, 5, and 3, 9. I know the line y equals 2x plus 3 has a y-intercept of 0, 3, and an x-intercept of, if I set y equal to 0, 0 equals 2x plus 3, minus 3 equals 2x, x equals negative 3 halves. So this line, 0, 3, goes like this. Oh, kind of like that, pretty close, you know. That's not too bad. So there's the line. And then the parabola y equals negative x squared plus 6x. So the vertex, well again, vx is negative b over 2a, which is negative 6 over 2 times negative 1, which is 3. Oh, let's say this point is going to be the vertex. And then the y value is going to be, if I plug in 3, I get negative 3 squared plus 6 times 3. Negative 3 squared, be careful, you have to do the squaring first, which gives you 9, but then it's negative 9, right? It's not negative 3 quantity squared, it's negative 3 squared. It's negative 9 plus 18, which is 9. So this point here is the vertex, and then the y-intercept for my parabola, if I set x equal to 0, I'm going to get 0 plus 0. So I'm going to get 0, 0 as my y-intercept. Right there. And then I do have x-intercepts. 0 is one of them, but I can find the x-intercepts by setting negative x squared plus 6x equal to 0. I would factor out a negative x, so I'm left with an x minus 6. So my intercepts are 0 and positive 6. So we look kind of like this. So we know that this line and my parabola intersect here and here, so it should be something like this. And graphing tools are really great. My graphing is not going to always be excellent. It's never going to be as good as the calculator does, but then we can shade the region between the 2 graphs. So that's what they're looking for on a question like this. Well, let's see. What else do I have in my notes here? I feel like I have one more example. Oh, I have 2 more examples. Yeah, let me look my notes on the computer real quickly here. Okay. Yes, 2 things. So I'll follow this. So the next example is asking us to find the equation of the line that is perpendicular to, so this this is the symbol for perpendicular. Perpendicular to y equals negative 3 halves x plus 17. And passing through the point passing the point 2, negative 5. So as I said before, to find the equation of a line, we need a point and a slope. We have a point, it's 2, negative 5. And we have a slope, we just have to know what it is. So if we're perpendicular to this line, y equals negative 3 halves x plus 17, that means our slope has to be positive, or has to be the opposite sign, reciprocal, 2/3. So then we can use either way of doing it. I like the point slope form, so I'm going to do y minus the y coordinate equal to my slope times x minus the x coordinate. And some people will be fine with you leaving it this way. I normally would, but a lot of teachers want you to actually kind of isolate y. So let's simplify this. So I'm going to have y plus 5. I'm going to distribute the 2/3. 2/3 times x is just 2/3 times x. 2/3 times minus 2 is minus 4/3. And then I'm going to subtract 5 from both sides. So y equals 2/3 x minus 4/3 minus 5. Minus 5 is really the same as minus 15/3. So I end up with y equal to 2/3 x. And then minus 4/3 minus 15/3 is minus 19/3. Sorry, this is pens. These pens are, I think it's time for some new pens. Alright, let's look at the last example. This last example is not so important. I don't think we often graph parabolas using the completing the square method, but we do complete the square for other things. And so it's kind of nice to talk about it in this context. So use completing the square to graph y equal to x squared minus 4x minus 5. Yeah, my pens are dying. I'm dying a sad death. So when you're completing the square, what you do is you take the coefficient of x, which is negative 4. You take that negative 4, you divide it by 2, and then you square it. And that's going to give us 4, which I actually want to write as negative 2 squared first. That's going to be negative 2 squared, which is 4. And what we do with that is we rewrite this equation as y equal to x squared minus 4x, and then we add and subtract that new value of 4. And then we still have the minus 5. And then what we do is we take these first 3 terms, these factor, and it always factors as something squared. That's going to factor as x minus 2 times x minus 2. And then minus 4 minus 5 is minus 9. And then what's nice about writing it in this particular format is that you can automatically see what the vertex is going to be. Here the vertex is going to be the coordinate 2, 9. It's always going to be the value of x that makes this part equal to 0. So if x is 2, 2 minus 2 is 0. And then if x is 2, well, y is going to be 2 minus 2 squared is 0 minus 9. So y has to be, oh sorry, minus 9, not positive 9. Apologies there. And again, if you think about it, this makes a lot of sense. If the vertex, in this case, is the lowest point, we're trying to find the value of x where y is the smallest. And y is going to be the smallest when this number here is the smallest. And the smallest a square thing can be, well, since it's always positive or 0, the smallest it can be is 0. So having x be 2 makes this quantity as small as possible, which makes this whole thing as small as possible. So that's one way you can kind of think about how, oh yeah, this has to be where the vertex is, because the value of x is making the value of y as small as possible. So the vertex is 2, negative 9. Looking back at the original form, it's easier to find that the y-intercept is 0, negative 5. Right, if we look at this format, you actually have to do a little more work to find the y-intercept. If you plug in 0, if you plug in 0 for x, 0 minus 2 is negative 2 squared is 4, and then 4 minus 9 is negative 5. So then we start graphing it. kill all the pins. But they're all down. So 2, -9 is down here. And then 0, -5 is maybe like right there. So we definitely have X-intercepts. They're gonna look something like this. Something I failed to say in class, but is definitely true, is that, so our vertex is at 2, -9. That means our intercepts, our X-intercepts are going to be equally to the left and right of 2. So they could be like at -1, which is 3 to the left, and +5, which is 3 to the right. Or some other choice of numbers. I think those are the numbers, but like, so however far it is to the left is also the same amount to the right. So it could be, you know, -2 and +6, or -3 and +7. It has to be equally spaced, because there's symmetry about, right, this line here, this vertical line that goes through the vertex is called the axis of symmetry. And it should look symmetrical about that line, but you know, my graph is not the best looking today. To find the X-intercepts, we're going to set y equal to 0, and then we factor, we get x minus 5 times x plus 1 equal to 0. So we get x equal to 5 and x equal to -1. Which, as I mentioned just moments ago, are equally spaced to the left and right of the value too, right? -1 is 3 to the left, +5 is 3 to the right. So hopefully that helps clarify any questions you might have about some of the homework problems. But if it doesn't, please feel free to get a hold of me. I'm happy to help with homework questions if you have any. All right, I will see you guys later.